Hey YouTube, Mr. B here. I'm here to give you guys an intro to recursion, looking at recursion with Python. Now, recursion is a concept that is similar to iteration, using for loops and while loops, repeating things. And when you think of the word recur, when we use it in the English language, for something to recur means it repeats. And so recursion is another form of repeating code. All right. Now, while loops and for loops are fairly simple. I've gone over those in the past, and recursion is a different way of doing it. And to be honest, it poses a bit of a challenge for a number of students. It's a different way of thinking about running code, and particularly, it has students. It has you creating a function and have a number of conditions in it, but then at some point in that function, you make a call to that function again, and it continues to call itself until certain conditions are met. And so we need to do a fair bit of thinking about how this is going to work before we start coding it. So I've got here, I'm using draw.io. They actually changed their domain now. It's app.diagrams.net. And it's because this is really useful to visualize what we're doing before we actually start coding. Okay. Now for the purposes of this, we're going to make a recursive algorithm that replicates the result of a number factorial. Now, if you need a reminder of what factorial means, I mean that's in math. We don't usually use that term normally in every day. But for instance, if we have 4 factorial in math, we represent it using an exclamation mark. That's the same as 4 times 3 times 2 times 1. All right. Now, when we do this manually, if we were to calculate this, then that would be 4 times 3 is 12, 12 times 2 is 24, and of course anything times 1 is itself, so this would be 24. What we want is to create an algorithm, a recursive algorithm, that will give us the result of it. And so this is how we're going to go about it. So to begin with, we're going to get input from the user, and for 4, it's fairly simple, all right? But we need to still make an algorithm that will do this. And so with the recursive algorithm, you need to think in terms of, all right, what do I know? Because we don't have a direct way of just resulting with the result of 4 factorial, unless you're using some built-in math command. For this, let's think of it in terms of one step with a reducing pattern, okay? So rather than breaking 4 factorial down into the entire product, we're going to break it down to 4 factorial is equal to 4 times 3 factorial. Or maybe I'll use an X for times, okay? Which is the same thing, isn't it? And so now we can break that down and go, okay, well, we don't necessarily know what 3 factorial is off the bat, but we know that 3 factorial is the same as 3 times 2 factorial. And we don't have 2 factorial right off the bat, but we do know that 2 factorial is equal to 2 times 1 factorial. Now, 1 factorial, should be self-explanatory. 1 factorial is the same as just 1. Now, as soon as we get to that place where whatever we're evaluating gives us an actual number, numerical result, now we can go backwards and replace the calls to that with the actual number. So, for instance, here, that means that 2 factorial is the same as 2 times 1, because now we know what 1 factorial is. And that, we know, is 2. Which means that if 2 factorial is 2, then 3 factorial is the same as 3 times 2, which is 6. And this 4 factorial is the same as 4 times 6, which is equal to 24. So all we're doing is replacing the calls to factorial with our result. And all factorial algorithms will follow this similar kind of pattern where we're starting with something where we break down the problem and we still have something unknown, but we're going to look for it with a reduced value. So here we've broken down 4 factorial into 4 times whatever 3 factorial is. And then 3 factorial is broken down into 3 times whatever 2 factorial is, etc. Until we get to, this is called the base case. All right, the base case where we can return an actual numerical value. And then it goes backwards. Okay, well, if 1 factorial is 1, then 2 factorial is actually 2, and 3 factorial is actually 6. Here, for 4 factorial, we're calling itself again 1, 2, 3 times. And when that last call of 3 or 4 times, I should say, 4 times, and that last call, we get the 1 and it goes back. It actually creates layers of calls to each other, onto itself. Okay, now let's just see what the code actually looks like. So here we are using Visual Studio Code, and we're going to make a function. I'm going to call it factorial, all right? And we're going to need a parameter for this. The parameter is going to be, I'm going to call it n, just because we want this to run with no matter what number we want. So we should be able to easily get, factorial of 150 just as well as we can get factorial of 4. Now, there are 2 kinds of recursive algorithms. There's head end and tail end, okay? And it has to do with when you are doing the recursion. When are you calling that function within itself again? And so this is going to be tail end. I'm going to give you an example of. So here, which means we have to start with our base case. What is our base case? What is known? So we know that if n is equal to 1, then we know what the result is. That would be the base case. So we're going to return 1. Now, since n is 1, we could also have return n. Either one works, all right? I kind of prefer return n. Else, so if that's not the case, n is not 1, it's something bigger than it, then I'm going to return n. So let's say and think in terms of 4 factorial. N would be 4 times n, which was 4 in the example we were looking at, minus 1. So if n was 4, then that means we're going to return n times, not n minus 1, but another call of factorial with n minus 1. This is where the recursion happens. We're calling itself again. And so the first time when n is 4, that will be false. It'll get down here and it's going to return 4 times the result of factorial 3, which means it's going to call it again and have an additional layer, additional call again and again and again. Eventually, it's going to have a call to n equal to 1, and that will give us an actual value, an integer, which means the previous call to factorial will have a known value, which means the call before that has a known value, etc., all the way back. Now, because you're creating so many calls, so many layers of calls to the factorial function, there is a limit. And there's a built-in limit to Python. I believe it's about 1,000 recursion depth. So it can only go down to 1,000 calls before it will give you an error saying you've got too many layers. And that's to protect your computer from using up too many resources and then crashing. Even though your computer potentially could handle more recursive calls, and you can change that limit. They put that default in to protect the general use of it. So now let's just try it. So because I'm returning it, I'm going to put the call to factorial inside of a print statement. And so here, let's just try it with 4. We should be expecting 24. Let's see what happens. And we get 24. Beautiful, right? What if we wanted to do factorial of 8? 40,320. That was a lot quicker than we could do that in our head. And we could even go up 150. Let's see what that is. Now that is a really big number, right? And so that's an example of just a really basic algorithm for recursion. All right. If you have any questions, please let me know. Happy to help out. Take care.